After testing 4-inch propellers on 1404 motors, I said that I wanted to see how they would perform on a larger motor, so I have a motor with almost the same kV, but double the stator size at 1408. As per my last video, the Gemfan floppy proppies have been eliminated since they couldn't take the power of the 1408 and exploded. This should be interesting.
Recursion Labs. For science.
This testing will be conducted on my updated variable controlled motor testing methodology, which you can learn more about in the video linked in the description. These tests were conducted at 16 volts to emulate a 4S battery. The motors used in this test are T-motor F1404 3800 kV, tested at an actual 3772 kV. T-motor F1408 3950 kV, tested at an actual 3834 kV. We will comparatively test the following 4-inch propellers: HQProp 2-blade 2.5-inch pitch propellers, Gemfan Hurricane 2-blade 2.4-inch pitch propellers, Gemfan Hurricane 3-blade 2.3-inch pitch propellers. I've already discussed the weight of these propellers in a previous video, so I'll skip it here. The 1408 motor weighs in at exactly 14.647 grams, which is 5.597 grams heavier than the 1404 motor, or 61.8%. Total weight of 4 motors comes in at 58.588 grams, which is 22.388 grams heavier than the 1404 motors. With the weigh-in complete, to test if size makes a difference, the best place to start with is thrust. I bet you can guess which 3 are 1404 and which 3 are 1408 without the legend. If you guessed the 1408 being the ones at the bottom, then, well, I guess I lost the bet. The 1408 clearly has more thrust across the entire throttle range, with up to 66.5% more thrust on Gemfan 2-blade. Speaking of which, looking at the light blue line, it appears tied with the HQProp 2-blade in dark orange up until around 75% throttle, where it quickly takes the lead and even ties up with the 3-blade Gemfan in green, which doesn't look very impressive so far. Switching to efficiency by motor utilization, in light orange at the top you see the 1404 2-blade Gemfan takes the lead for 80% of the throttle range for efficiency, up until the 1408 2-blade Gemfan in light blue takes over for the lead. This alone shows that thrust output and motor weight aside, the 1404 motor might be the perfect choice for a 4-inch long-range build where you want to get the longest possible cruising flight times. After that, the efficiency is almost equal outside of the 1408 Gemfan 2-blade in light blue, which is almost always more efficient than the HQProp 2-blade in dark orange. Now for the most important chart: grams of thrust to watts of power. Okay, that's a huge difference. 66% of additional thrust looks more significant looking at it this way. What is interesting here is that thrust aside, the upper thrust range for the graphs looks similar for the same propeller on different motors. On both motors, the Gemfan 2-blade takes the lead for overall performance and efficiency. The HQProp 2-blade and the Gemfan 3-blade are both very similar for both thrust and efficiency, except the 3-blade edges out in thrust on the 1408 motor. Enhance! Like we saw in the efficiency chart, the first 150 grams of thrust goes to the 1404 propellers, with the Gemfan 2-blade in light orange marginally winning out. Between 150 and 400 grams, the 1408 motors quickly takes the lead for efficiency, with the Gemfan 2-blade in light orange leading, followed by the 3-blade in dark blue. Moving up, after 250 grams, we can see the 2-blade Gemfan on 1404 start to lose its efficiency advantage. But at 250 grams, we're at a 4-to-1 thrust-to-weight ratio, which is probably double cruise speed for a long-range aircraft. Looking at 0 to 650 grams, we can see that for pure top-end performance, you get more thrust for your watt on a larger 1408 motor. Removing the 4-inch 1404 propellers and overlaying the 3.5-inch HQProp 3-blade 2.5-inch pitch propeller we tested previously on the 1408 in dark purple, we can see that it is much less efficient. Now let's swap that for the same propeller on a 1404 motor. Let's try to decide if it's worth the 22-gram weight cost for upgrading the motor for 4-inch, plus additional frame weight. Looking at the top end of the 3.5-inch, we have 98 grams of additional thrust per motor for the same wattage, which works out to 22.8%. Enhance! Going back to 150 to 400 grams, if we measure the difference at around 300 grams of thrust, we get 52 grams of additional thrust per motor, or 17.2%. At 198 grams, we have a difference of 26 grams of thrust, or 13%. These are diminishing returns, and once we move down to the first 150 grams of thrust, the additional thrust probably wouldn't be worth the added motor and frame weight. Now, let's look at the full graph. This is where I start to get a bit concerned. On the surface, this looks amazing. The 3.5-inch on 1404 looks soundly defeated, and for thrust it is because it's nearly double. The problem with this is the top-end energy requirements also significantly increases, requiring 74% additional current to properly power this. This means we're looking at a 4S 1300 mAh battery to be equivalent. but could probably get away with 1,000 if the top end throttle wasn't used as much. But either way, we're adding more weight, and it might make it impractical to stay under 250 grams if that's the goal. The answer could be to add a throttle output limit in beta flight to cap the throttle. But doing that by design means we are throwing away efficiency, which we proved in the test and video where we tested the impact of using that. The smarter alternative here is to use a motor with a lower KV, which means I have more testing to do to fully hash this out. Regardless, I can see why 4-inch quads get such a bad reputation, because it would be really easy to get the balance wrong here and end up with a quad that flies like an underpowered 5-inch. Here are the throttle motor response time graphs when we spin up the motor from idle to 90%. The 3-blade Gemfan in green does seem to be struggling here, which becomes more apparent if we overlay an aggressive 3-inch propeller on the 1404 motor, supporting the theory that the KV may be too high here. Using the RPM data to calculate the propeller tip speed, we can see that the 2-blade Gemfan reaches a whopping 729 kilometers per hour, which is Mach 0.6. I guess I should stop moving my appendages near the test stand when this thing is spinning, especially if it's a floppy proppy. That's all for now, but I would love to hear your thoughts. I do have 2800 kV 1408 motors that I was planning to test 5-inch propellers on, but perhaps now I'll test 4-inch as well. More to come.